Good morning, my dear students. Last class we have been studied the method of solving the homogeneous differential equations, and before that we have been studied the solving the differential equations by using the variable separable method. So today I am going to discuss the method of solving the linear differential equations, and this is also very most important for your examination purpose. So first thing, what is meant by a linear differential equation? Any differential equation is of the form dy by dx plus py is equals to q, where p and q are constants are functions of x, or the differential equation is of the form dx divided by dy plus px is equals to q, where p and q are constants are functions of y, Such type of differential equations are known as linear differential equations. When differentiation of y with respect to x is exist, then p and q are functions of x, are constants. When differentiation of x with respect to y is exist, then p and q are functions of y, are constants. And which is the method of solving these linear differential equations? And for your syllabus, this year the method of solving the linear differential equation of the form dx by dy plus px is equals to q will not consider for your examination. So I just discussed the method of solving the differential equation of the form dy by dx plus py is equals to q. So for that, I just took an example as a question number 2 in exercise 9.6. Why? Because this question is very easy to understand the method of solving a linear differential equation. So the question is, find the general solution of the differential equation dy by dx plus py is equals to e power minus 2x. And you just observe here, this differential equation of the form dy by dx plus py is equals to q, where the value of p is 3 and the value of q is e power minus 2x, where the value of p is 3 and the value of q is e power minus 2x. After writing p and q from the given differential equations, then we need to find out the integrating factor of the given differential equation. The next thing is what? Integrating factor. IF means what? Integrating factor. And the formula to find the integrating factor of the given differential equation is e power integration of p dx. E power integration of p dx is the formula to find out the integrating factor of the given differential equation, which is equals to e power integration of the value of p is 3 dx, which is equals to e power 3 is constant taken outside the integration of dx is x. Therefore, the integrating factor of the given differential equation is e power 3x. After finding the integrating factor, we need to find out the general solution of the given differential equation. And the formula to find the general solution of the given differential equation of the form dy by dx plus py is equals to q is general solution is y into integrating factor is equals to integration of q into integrating factor with respect to x plus integral constant c. This is the general solution of the linear differential equation of the form dy by dx plus py is equals to q. So now y as it is, integrating factor is e power 3x, which is equals to integration of q. The value of q is e power minus 2x. So e power minus 2x into integrating factor is e power 3x with respect to x plus integral constant c. Now, so y into e power 3x, which is equals to integration of e power minus 2x into e power 3x is e power 3x minus 2x. E power 3x minus 2x is e power x with respect to x plus integral constant c. So therefore, the value of y into e power 3x is equals to integration of e power x is e power x plus integral constant c. Or the value of y is equals to e power x divided by e power 3x plus c divided by e power 3x. Now 1 e power x get cancelled. The remaining is 1 divided by e power 2x. And shift this e power 2x towards the numerator. We get what? Y is equals to e power minus 2x plus c into 1 divided by e power 3x. Shift this e power 3x towards the numerator. It becomes what? E power minus 3x. And this is the required general solution for the given differential equation. And the method of solving linear differential equation is, first we should write the given differential equation in the form of dy by dx plus py is equals to q. After that, we find the values of p and q. Then we needed to find out the integrating factor of the given differential equation by using the formula e power integration of p dx. Then these values of q and p and integrating factor will be substituted in the general solution of the given differential equation, and the general solution of the linear differential equation of the form dy by dx plus py is equals to q is y into integrating factor is equals to integration of q into integrating factor dx plus integral constant c. Next up to both the other integration. I hope all of you understood. If possible, take a look. So now the third question, find the general solution of the differential equation dy by dx plus y by x is equals to x square. And you just observe the given differential equation. This differential equation is also of the form of dy by dx plus py is equals to q, where the value of p is equals to dy by dx plus 1 by x into y. Therefore, the value of p is 1 by x and the value of q is equals to x square. So next we need to find out the value of integrating factor, and the formula for integrating factor is e power integration of p dx, which is equals to e power integration of the value of p is 1 by x with respect to x, so which is equals to e power integration of 1 by x dx is log x. And you just consider the note here. So note is nothing but if e power log of fx is present, if e power log of fx is present, then the value of e power log of fx is equals to fx. This is the very most important one when we are solving the linear differential equation. We just observe here, integrating factor is e power log x. The value of fx is x here. So e power log of fx is fx. Therefore, e power log x is equals to x. The integrating factor of the given differential equation is equals to what? X. Hence, the general solution of the given differential equation is the formula is y into integrating factor is equals to integration of q into integrating factor with respect to x plus integral constant c. Now substitute the value of q and integrating factor. So y into integrating factor is x, which is equals to integration of the value of q is x square into integrating factor is x with respect to x plus integral constant c. So y into x is xy, which is equals to integration of x square into x is x cube with respect to x plus integral constant. Therefore, the value of xy is equals to integration of x cube is x raised to 4 divided by 4 plus integral constant c. And this is the required general solution for the given differential equation. I hope all of you understood. If possible, take a note. So now the fourth question is find the general solution of the differential equation dy by dx plus secant x into y is equals to tan x. So this differential equation is also of the form of dy by dx plus py is equals to q, where the value of p is equals to secant x and the value of q is equals to tan x. Next, integrating factor of the given differential equation is e power integration of p dx, which is equals to e power integration of the value of p secant x dx. So which is equals to e power of integration of secant x is log of secant x plus tan x. So this is in the form of e power log fx, and the value of e power log fx is fx. The value of fx is secant x plus tan x. Secant x plus tan x. Therefore, integrating factor of the given differential equation is secant x plus tan x. Next is the general solution of the given differential equation. So general solution is y into integrating factor, which is equals to integration of q into integrating factor with respect to x plus integral constant c. Now, y as it is integrating factor is secant x plus tan x. Secant x plus tan x, which is equals to integration of q is tan x. Tan x into integrating factor is secant x plus tan x with respect to x plus integral constant. Now, so y into secant x plus tan x is equals to integration of tan x into secant x, tan x into secant x dx plus integration of tan x into tan x, tan square x dx plus integral constants. Now, which is equals to integration of tan x into secant x dx is secant x plus integration of tan square x can be written as secant square x minus 1 with respect to x plus c. Therefore, secant x plus integration of secant square x is tan x minus integration of 1 dx is x plus integral constant. Therefore, the required general solution of the given differential equation is y into secant x plus tan x is equals to secant x plus tan x minus x plus c. I hope all of you understood. If possible, take a look. Now the fifth question is find the general solution of the differential equation cos square x into dy by dx plus y is equals to tan x. But we know the standard form of the differential equation is dy by dx plus py is equals to q. Therefore, first convert the given differential equation in standard form. For that, we need to divide throughout the equation by cos square x. ಏನು ಮಾಡ್ತಾ ಇದ್ದೀನಿ ನಾನು divide throughout by what cos square x. Now what cos square x get cancelled, remaining divide by dx plus 1 by cos square x is secant square x into 1, which is equals to tan x divided by cos square x means tan x into 1 by cos square x is secant square x. On comparing these two, we get the value of p is equals to secant square x and the value of q is equals to tan x into secant square x. Now integrating factor. The formula for integrating factor is e power integration of 3 dx, which is equals to e power integration of p secant square x. So which is equals to e power integration of secant square x dx is tan x. Therefore integrating factor of the given differential equation is e power tan x. Now the general solution is y into integrating factor, which is equals to integration of q into integrating factor with respect to x plus integral constant c. So y into integrating factor is e power tan x, which is equals to integration of q is tan x into secant square x, tan x into secant square x into integrating factor is e power tan x with respect to x plus integral constant. To find the integration of tan x into secant square x into e power tan x, differentiation of tan x is secant square x. Therefore, we just substitute the value of tan x is equals to t. ಏನು ಮಾಡ್ತಾ ಇದ್ದೀನಿ ನಾನು put tan x is equals to t. Since t is a function of x, differentiate with respect to x. Differentiation of tan x is secant square x dx is equals to t. Therefore, the above equation becomes y into e power tan x means e power t, which is equals to integration of tan x is t into e power tan x means e power t into secant square x into dx is equals to what t plus integral constant c. Now t into e power t, integration of t into e power t to be solved by using integration by parts method. So by applying Eigen rule, the first function is t and the second function is exponential function e power. So if y into e power t is equals to first function t as it is, integration of e power t is e power t minus integration of differentiation of first function t with respect to t is 1 into integration of second function e power t is e power into dt plus integral constant c. Therefore, y into e power t is equals to t into e power t minus 1 into e power t is e power t. Integration of e power t is e power t plus c. Now, in between these two, we may take e power t as common. So y into e power t is equals to e power t remaining t minus 1 plus integral constant. So therefore the value of y is equals to e power t into t minus 1 divided by e power t. Shift this e power t towards the right hand side plus c divided by e power t. ಎರಡು divide ಆಗುತ್ತೆ. E power t and e power t get cancelled. So therefore the value of y is equals to t minus 1. The value of t is what? Tan x. So tan x minus 1 plus c divided by e power tan x, or the value of y is equals to tan x minus 1 plus c into e power minus tan x. 1 divided by e power tan x and 1 e power minus tan x. And this is the required general solution for the given differential equation. I hope all of you understood. If possible, take a note. Now the sixth question is find the general solution of the differential equation into dy by dx plus 2y is equals to x square log x. But this given differential equation is not in standard form. The standard form of the linear differential equation is dy by dx plus py is equals to q. To convert the given differential equation in standard form, we just divide throughout the given differential equation by x. So here x and x get cancelled. Here x and 1x get cancelled. Remaining dy divided by dx plus 2 by x into y, which is equals to x log x. So on comparing these two, we get the value of t is equals to 2 by x and the value of q is equals to x into log x. So after that, the integrating factor is e power integration of p dx, which is equals to e power integration of the value of p is 2 by x into dx, which is equals to e power integration of 2 by x. 2 is constant taken outside the integral. So integration of 1 by dx is log x. So hence the integrating factor of the given differential equation is e power n log m is equals to log m power n. So log of x square. Now this is in the form of e power log fx. The value of e power log fx is fx. Value of fx is x square. Hence integrating factor of the given differential equation is x square. Now what? General solution of the given differential equation. Y into integrating factor is equals to integration of q into integrating factor with respect to x plus integral constant. Now, so y into integrating factor is x square, which is equals to integration of q. The value of q is x log x. X log x into integrating factor is x square. So x square with respect to x plus. Next, x into x square is x cube. Now integration of x cube log x by using integration by parts method, by considering the rule of I. First function is logarithmic function and the second function is x cube. Therefore, y into x square is equal to first function log x as it is. Integration of x raised to 3 is x raised to 4 divided by 4 minus integration of differentiation of first function. Log x differentiation is 1 by x into integration of second function is x raised to 4 divided by 4 with respect to x dx plus integral constant c. Now 1x get cancelled. The remaining is y into x square is equals to x raised to 4 divided by 4 into log x minus 1 by 4 is constant taken outside the integral. Remaining integration of x raised to 4 and 1x cancel by the remaining x cube. Again integration of x raised to 3 is x raised to 4 divided by 4 plus integral constants. Hope all of you understand. Now here 1 by 4 into 1 by 4 is 1 by 16. So y into x square is equals to x raised to 4 divided by 4 log x minus x raised to 4 divided by 16 plus c. Now in between these two, LCM is 16. So multiply by 4. So y into x square is equals to 4 into x raised to 4 into log x minus x raised to 4 divided by 16 plus integral constant c. Now in between these two, we may take x raised to 4 as common. So y into x square is equal to x raised to 4 divided by 16 into the remaining term is 4 log x minus 1 x raised to 4 is common plus integral constant. Therefore, the value of y is equal to x raised to 4 divided by 16 into x square as I told you into 4 log x minus 1 plus c divided by x square. X square and divided. Now x square and x square get cancelled. Remaining x raised to 4 and x square cancel together. Remaining x square. Therefore, the value of y is equal to square divided by 16 into log x minus 1 plus c into x raised to minus 2. X square mathematical. So this is the required general solution for the given differential equation. I hope all of you understood. If possible, take a note. So now the seventh question is, find the general solution of the differential equation x log x divided by dx plus y is equal to 2 by x into log x. So we know that the standard form of linear differential equation is dy by dx plus dy is equal to q, but the given differential equation is not in standard form. So to convert the given differential equation in standard form, we just divide throughout equation by what? X into log x. So divide throughout by what? X log x log x, and divided by what? X log x. Here x log x get cancelled, remaining what? Dy by dx plus here 1 divided by x into log x into what? Y, which is equal to, here log x and log x get cancelled, remaining 2 by x into 1 by x is equal to what? 2 by x square. So comparing these two, we get the value of p is equal to 1 divided by x log x, and the value of q is 2 divided by x square. Now what integrating factor of the given differential equation is e power integration of p dx, which is equal to e power integration of p is what? 1 divided by x log x, 1 divided by x log x. So 1 divided by x log x with respect to x t. This 1 divided by x log x can be written as 1 by x divided by log x into 1 over. Now differentiation of log x is 1 by x. So integration of f dash x divided by fx. Integration of f dash x divided by fx dx is what? Log of fx. The value of fx is log x. So which is equal to e power integration of 1 by x log x is log of fx under log x. Log. Which is equal to the value of integrating factor is, now it is in the form of e power log fx. The value of e power log fx is fx. Value of fx is log x. Hence, the integrating factor of the given differential equation is log x. Next, we need to find out the general solution. The general solution of the given differential equation is y into integrating factor, which is equal to integration of q into integrating factor with respect to x dx plus integral constant. No. So y into integrating factor is log x, which is equal to q. The value of q is 2 by x square into integrating factor is log x with respect to x plus c. Now 2 by x square into log x and 2 is constant. So taken outside the integral, 2 into integration of 1 by x square log x dx plus c. Now 1 by x square into log x, algebraic function, logarithmic function. So log x is the first function, 1 by x square is the second function. So y into log x is equal to 2 into first function log x as it is, log x as it is. Integration of second function is 1 by x square. So integration of 1 by x square can be written as integration of x power minus 2 dx, and integration of x power minus 2 dx is equal to x power minus 2 plus 1 divided by minus 2 plus 1, which is equal to x power minus 1 divided by minus 1, which is equal to minus 1 divided by x. X power minus 1 1 by x into as it is minus. Therefore, integration of second function is minus 1 by x. Minus 1 by x. Minus integration of differentiation of first function, differentiation of log x is 1 by x into integration of second function is minus 1 by x, minus into minus plus 1 by x with respect to x plus integral constant c. Now what? So y into log x is equal to 2 into minus 1 by x into log x, minus 1 by x into log x plus integration of 1 by x into 1 by x is what? 1 divided by x square, and integration of 1 by x square is minus 1 by x. So integration of 1 by x square is minus 1 divided by x plus integral constant c. Now plus into minus, minus. So y log x is equal to 2 into minus 1 by x log x minus 1 by x plus c. Now in between these two we may take minus 1 by x as common. So therefore y into log x is equal to minus 1 by x is common, minus 1 by x into 2 minus 2 by x. Remaining term is log x plus 1 plus integral constant, and this is the required general solution for the given differential equation. I hope all of you understood. If possible, take a note. So now the eighth question is find the general solution of the differential equation 1 plus x square dy plus 2xy dx is equal to cot x dx. First we need to convert this given differential equation in standard form. Dy by dx plus dy is equal to q. Therefore we need dy by dx. Therefore first divide throughout the given differential equation by dx. Then coefficient of dy by dx will be equal to 1. Therefore I will divide this throughout equation by what? 1 plus x square. 1 plus x square and what? 1 plus x square. Now 1 plus x square, 1 plus x square get cancelled. Dx get cancelled. Dx get cancelled. The remaining is dy by dx plus 2x divided by 1 plus x square into 1 is equal to cot x divided by 1 plus x square. On comparing these two, we get the value of p is equal to 2x divided by 1 plus x square, and the value of q is equal to cot x divided by 1 plus x square. Now integrating factor. So integrating factor is equal to e power integration of p dx, which is equal to e power integration of p is 2x divided by 1 plus x square, 2x divided by 1 plus x square with respect to x dx. And the differentiation of 1 plus x square is 2x. Therefore this is in the form of integration of f dash x divided by fx. So integration of f dash x divided by fx is log of fx plus c. Therefore which is equal to e power log of fx. The value of fx is 1 plus x square, and which is equal to, this is in the form of e power log fx. The value of fx is 1 plus x square. So e power log fx is fx. Therefore integrating factor is 1 plus x square. Next, the general solution of the given differential equation y into integrating factor, which is equal to integration of q into integrating factor with respect to x plus integral constant c. Now so y into integrating factor is 1 plus x square, which is equal to integration of q. The value of q is cot x divided by 1 plus x square, cot x divided by 1 plus x square into integrating factor. Integrating factor is 1 plus x square into 1 plus x square with respect to the x plus c. Now 1 plus x square, 1 plus x square get cancelled. Therefore remaining y into x dx plus c. Therefore, y into 1 plus x square is equals to integration of cot x is log of sin x plus integral constant c. And this is the required general solution for the given differential equation. I hope all of you understood. If possible, take a note. So now the ninth question is, find the general solution of the differential equation x into dy by dx plus y minus x plus xy cot x is equal to 0. First, we need to convert the given differential equation in standard form. Dy by dx plus py is equal to q. So for that, x into dy by dx, first term as it is. Now for py, y is common in second and fourth term. So let's take y as a common. The remaining term in the second term is 1 plus in the fourth term y is common. Remaining term is x into cot x. So x into cot x into the common term y, which is equal to, shift this minus x towards the right hand side, it becomes plus x. Still this differential equation is not in standard form. Why? Because dy by dx is multiplied with x. Therefore, divide throughout this equation by x. Divided by x. And now this 1 plus x cot x divided by x can be written as 1 divided by x plus x cot x divided by x. So x and x get cancelled, dy by dx plus 1 by x plus here x and x get cancelled, cot x into 1, which is equal to x and x get cancelled, 1. On comparing these two, we get the value of p is equal to 1 by x plus cot x, and the value of q is equal to 1. Next thing is integrating factor. So now integrating factor is equal to e power integration of p dx, which is equal to e power integration of, the value of p is 1 by x plus cot x, 1 by x plus cot x with respect to x, which is equal to e power integration of 1 by x dx is log x plus integration of cot x is log of sin x, which is equal to e power log m plus log n is equal to log mn. So log x plus log of sin x is equal to log of x into sin x. Therefore, integrating factor is equal to e power log of fx. The value of fx is x into sin x. Therefore, integrating factor is x into sin x. Next thing is what? General solution of the given differential equation. Integrating factor is so integrating factor of the given differential equation is x into sin x. Now, general solution is, so general solution is y into integrating factor, which is equal to integration of q into integrating factor with respect to x plus c. So y into integrating factor is x into sin x, which is equal to integration of q. Q is 1 into integrating factor is x into sin x with respect to x plus c. Now 1 into x into sin x is x into sin x. So integration of x into sin x dx by using highlight rule. The first function is algebraic function x and the second function is trigonometric function sin x. Therefore, so y into x sin x, which is equal to first function x as it is. The integration of sin x is minus cos x minus integration of differentiation of first function x with respect to x is 1 into integration of second function integration of sin x is minus cos x minus into minus plus cos x with respect to x plus. Therefore, so y into x sin x is equals to minus x cos x. Integration of 1 into cos x is integration of cos x. Integration of cos x is sin x plus sin x plus c. So therefore the value of y is equals to minus x cos x divided by x sin x plus sin x divided by x sin x plus c divided by x sin x. Now x sin x get cancelled, therefore the value of y is minus of cos x divided by sin x is cot x plus sin x and sin x get cancelled, 1 by x plus c divided by x into sin x. And this is the required general solution for the given differential equation. I hope all of you understood. If possible, take a note. Now the first question is, find the general solution of the differential equation dy by dx plus 2y is equals to sin x. And this differential equation is of the form dy by dx plus py is equals to q, where the value of p is equals to 2 and the value of q is equals to sin x. Therefore, the integrating factor of the given differential equation is e power integration of p dx, which is equals to e power integration of the value of p is 2, so 2 dx, which is equals to 2 is constant taken outside the integral e power 2 into integration of dx is x. Therefore, integrating factor of the given differential equation is e power 2x. Next is what? General solution. Y into integrating factor, which is equals to integration of q into integrating factor with respect to x plus integral constant, and y into integrating factor is e power 2x, which is equals to integration of q, the value of q is sin x, into integrating factor is e power 2x with respect to x plus c. And let us consider this is what first equation. Now we need to find out the integration of sin x e power 2x dx. So let us consider that the value of I is equal to integration of sin x into e power 2x dx. By using the I rule, the first function is sin x and the second function is e power 2x. Integration by using parts method. The value of I is equal to first function sin x as it is into integration of e power 2x is e power 2x divided by 2 minus integration of differentiation of first function, differentiation of sin x is cos x, into integration of second function is e power 2x divided by 2 with respect to x plus integral constants. Next thing is what? Cos x into integration of cos x into e power 2x divided by 2. So 1 by 2 is constant taken outside the integral. 1 by 2 is constant. Again, integration of cos x into e power 2x, we need to apply the parts method. So for that, cos x is first function and e power 2x is second function. Therefore, the value of I is equal to sin x into e power 2x divided by 2 minus 1 by 2 into, so first function cos x as it is into integration of second function e power 2x divided by 2 minus integration of differentiation of cos x is minus sin x, minus into minus plus sin x, into integration of second function, integration of e power 2x is e power 2x divided by 2 with respect to x plus c. Now, the value of I is equal to sin x into e power 2x divided by 2 minus 1 by 2 into cos x into e power 2x by 2 is minus 1 by 4 into cos x into e power 2x. 1 by 2 into 1 by 2 is 1 by 4. minus into plus minus. So here e power 2x divided by 2 is present. So 1 by 2 is constant. So e power 2x ಹೊರಗೆ ತಗೊಂಡಿದ್ದೀನಿ 1 by 2. Now minus into plus minus 1 by 2 into 1 by 2 is 1 by 4. Remaining integration of sin x into e power 2x dx plus c plus c. Now integration of sin x into e power 2x dx is I. Therefore, in place of this we may substitute I. Hence, I is equal to, in between first two terms, we may take e power 2x divided by 4 as common, or e power 2x is common, then LCM is 4. In between these two terms, LCM is 4. LCM of 2 and 4 is 4. Therefore, minus LCM is to here multiply by 2 divided by 4. Now e power 2x divided by 4 is common. E power 2x divided by 4. The remaining term is 2 into sin x. Sorry, this is sin x. 2 into sin x minus cos x. E power 2x by 4 is common. Minus 1 by 4 into this total term is I plus c. Now shift this minus 1 by 4 I towards the left hand side. It becomes what? Plus 1 by 4 I plus 1 by 4 I. Now 1 by 4 I plus I. LCM is 4. 1 I plus 4 I is equals to 5 I divided by 4, which is equals to e power 2x divided by 4 into what? 2 sin x minus cos x plus c. Now shift this 5 by 4 towards the, because we need to find out the value of I. So shift this 5 by 4 towards the right hand side. It becomes what? 4 by 5. Hence the value of I is equals to 4 by 5. 4 and 4 get cancelled. Hence we get the value of I is 1 by 5 into e power 2x into 2 sin x minus cos x plus 4 and 4 get cancelled. What is the remaining thing? E power 2x divided by 5. Substitute this value of I in equation number 1. Hence the value of equation 1 equals y into e power 2x is equals to e power 2x divided by 5 into 2 sin x minus cos x plus c. Then shift this e power 2x towards the right hand side. This will becomes 1 divided by e power 2x and c divided by e power 2x. E power 2x and e power 2x get cancelled. The remaining term is 1 by 5 into 2 sin x minus cos x plus c divided by e power 2x becomes what? C into e power minus 2x. And this is the required general solution